Okay, here we have the first two sections for Chapter 5. They're put together because they're pretty short, relatively speaking. Angles and degree measures, and then trigonometric ratios and right triangles. So for 5.1, the number of degrees in a given number of rotations, and identify the angles that are coterminal. And 5.2, trig ratios for acute angles that are in right triangles. Here we just got the definition of what an angle is. You rotate one of two rays that share a fixed endpoint, that's called the vertex, and then the side that is stationary is the initial side, and the part that rotates is the terminal side, so that gives us your angle alpha. So the measure of the angle tells you how the angle was rotated. Angle of rotation in the counterclockwise is positive, clockwise rotation is a negative angle. If the vertex is at the origin and its initial side is along the x-axis, you have what's called a standard position. And if the terminal side ends up on one of the axes, the x or the y-axis, that's a quadrantal angle, because it draws the quadrants of the right triangle, or of the axes. So, example 1, identify all angles that are coterminal with each angle, then find one positive angle and one negative angle that are coterminal. So now, coterminal means the angles have to end in the same place. If that happens, that means they differ by a full rotation. And in degrees, a full rotation is 360 degrees. So all the coterminal angles would be 45 degrees plus or minus 360 degrees. So that's all the coterminal angles. So one that's positive, well, I'll just take 45 and add 360. So one of them is 405 degrees, and take the 45 minus the 360. There's another one at negative 315 degrees. So there's an infinite number of angles that are coterminal, because you can just keep spinning around and around and around until you decide to stop. So for this one, all the angles would be 225 plus or minus 360. So one of them would be 585, there's the positive angle, and negative 135, there's the negative angle. Now if your angle is large enough, like more than 360, and you're looking for a negative coterminal angle, you may have to subtract 360 more than once until you get to a negative value. Alright, so here we go. Each angle is in standard position. Determine a coterminal that's between 0 and 360, and then state the quadrant in which the terminal side lies. So this is more than 360. So to get it down between 0 and 360, we're going to have to subtract 360 degrees. So 775 minus 360, well, that's 415. That's still not small enough, so we're going to have to subtract another 360. So 415 minus 360 is 55 degrees. So there's the coterminal angle between 0 and 360. State the quadrant. If you don't recall, here's your quadrants. They meet at right angles, so the first quadrant is from 0 degrees to 90. The second quadrant is from 90 to 180. Quadrant 3 is from 180 to 270. And then quadrant 4 is from 270 to 360, which happens to be the same location as 0 degrees. So a 55 degree angle is in quadrant 1, because it's between 0 and 90. So negative 1297, we're going to have to add 360s because you've got a negative angle. So adding 360 once gives you negative 397, which isn't between 0 and 360, so we have to add another one. Still not big enough. Still not big enough. 143. So that's between 0 and 360. 143 is between 90 and 180, so this angle is in quadrant 2. So if alpha is a non-quadrantal angle in standard position, its reference angle measures the distance back to the x-axis, shortest direction. So it's never going to be more than 90 because it says it's an acute angle. So there's a rule to find out, depending on where your angle is, what the reference angle is. If your angle is in quadrant 1, the reference angle is the same as the angle. If it's in quadrant 2, you'd have to take 180 minus your angle. That'll be the reference. In quadrant 3, it's your angle minus 180, and in quadrant 4, it's 360 minus your angle. So this one says find the measure of the reference angle for each angle. So 120 degrees, this angle is in quadrant 2. And in quadrant 2, you take 180 minus alpha, so that's going to be 180 minus 120, so the reference angle is 60 degrees. Negative 135, the first thing I need to do is actually make this a positive angle, so I'm going to add 360. So that is a 225 degree angle. 225 is in quadrant 3, and for quadrant 3, you're going to take your angle minus 180, so that's 225 minus 180. So this reference angle is 45 degrees. So this is where we switch to 5.2. In a right triangle, lots of typos today. That should be 1 of the angles measures 90 degrees, and the remaining 2 angles are acute, and they're also complementary. So they're both less than 90, and if you add them up, they equal 90. So that's what complementary means. The longest side is referred to as the hypotenuse. The other 2 sides are called the legs. Now, if you're talking about your angle, the leg that is adjacent to the angle is the adjacent side, or side adjacent, and the side opposite the angle is the opposite side, or side opposite. So here's just general definitions. So sine, cosine, and tangent, they're abbreviations, and then the rules given this triangle. So this theta down here is the angle we're talking about. So the sine of theta is the opposite divided by the hypotenuse, cosine is the adjacent divided by the hypotenuse, and tangent is opposite divided by adjacent. So this one says find the values of sine, cosine, and tangent for angle B. So here's angle B right there. So that means this is the opposite side, this is the adjacent side, and this is the hypotenuse. If you notice, you're actually missing the adjacent side. So even though it's not in the notes, hopefully this equation is familiar to you. It's the Pythagorean theorem. A squared plus b squared equals c squared, where c is the hypotenuse. So our adjacent side, we'll just call a. So a squared plus 18 squared equals 33 squared. A squared plus 324 equals 1089. A squared is 1089 minus 324, or 765, which is not perfect. Let's see what goes into it. Nine is the biggest perfect square, so a is equal to the square root of 765, which is 3 root 85. So the sine of b will be the opposite side divided by hypotenuse, 18 over 33. The cosine of b will be the adjacent side, 3 root 85 over 33, which reduces, now this one reduces too, it's 6 over 11. And the tangent of b is the opposite side, 18 over the adjacent side, 3 root 85. Which would reduce to 6 over root 85. You cannot have a root on the bottom, so you have to multiply the top and the bottom by the square root. 6 root 85 over 85, and I don't know if 6 85ths reduces. It sure doesn't, so it's 6 85 over 85. Alright, these are the reciprocal trig functions, cosecant, secant, and cotangent. So cosecant is the reciprocal of the sine, secant is cosine, and cotangent is reciprocal of the tangent. So once again, same triangle down here as before. So this one's, so if the cosine of theta is 3/4, find secant. Well, secant is the reciprocal. Secant of theta is the reciprocal of the cosine. The reciprocal of 3/4 is 4/3. Here, if cosecant is 1.345, well, the cosecant is the reciprocal of the sine, so I need the reciprocal of, oops, sorry, did that backwards. I'm looking for sine. Sine is the reciprocal of the cosecant, So I need the reciprocal of 1. Yeah, so 1 divided by 1.345. So the sine of theta in this case is 0.7435. You take the reciprocal or divide 1 by the number. The last thing here is there's some common angles that you see a lot, 30, 45, and 60s, and then the values of the sine, cosine, tangent, and then the reciprocal functions for each of those values. Also down here, cofunctions, so like sine and cosine, tangent and cotangent, secant and cosecant. Complementary angles add to 90, so that what this says is that the cofunctions of complementary angles are equal. So that means that the sine of 30, for example, is equal to the cosine of 60. The cofunctions and these angles are complementary. So this is true for anything. The tangent of 45 is equal to the cotangent of 45. So as long as the angles add to 80. The secant of, or 90, sorry, the secant of 15 is equal to the cosecant of whatever 9 is 75. So that's the general rule there.